This is Calculus with Mr. Allenson, and today we're going to be doing problem 2 from Form B of the 2002 BC test. So it starts out with a function P of t, which is the amount of pollution in a lake. They give you P prime of t, which is 1 minus 3e to the negative 0.2 root t gallons per day, so the rate that the pollution is changing in the lake. A asks, is the amount of pollutant increasing at t equals 9? So we just want to look at the rate when t is 9. We can simply plug that into our calculator and find out that we get negative 0.646, which is less than 0, so the amount is not increasing. B, for what value of t will the number of gallons of pollutant be at its minimum? So for it to be at its minimum, that's going to happen when the derivative is equal to 0. So I'm going to go with 1 minus 3e to the negative 0.2 root t equals 0. Add this to the other side, divide by 3. Basically work out with the natural log and solve, and I'm going to get t is equal to 30.174. Okay, so this is the value when it's at its minimum, and the way that we know that that's true, we can show that, is that P prime of t is negative from 0 to 30.174, and P prime of t is positive for t is greater than 30.174. So therefore this is it's a minimum at 30.174. C says, is the lake safe when the number of gallons of pollutant is at its minimum? So at this time right here, is the lake have a pollutant at its minimum? I'm going to take the integral from 0 to 30.174 of P prime of t dt, and this is how much it's changed by. It started with 50, so I have to add the 50. And when I do this, I get 35.104, which is less than 40, so the lake is safe. Okay. D asks about a tangent line that approximates this P of t function and its tangent at 0. Using that as a model for the amount of pollutant in the lake, what time does the model predict the lake will be safe? So using a model, the point that they're giving you is 0, 50. At time 0 there's 50. And then I'd want to find the slope at 0, basically P prime of 0. P prime of 0, if I plug in 0, I get 1 minus 3, or negative 2. So my linear equation would actually be y equals negative 2x plus 50, this being the y-intercept, that being the slope. And so I'm wondering when this is going to give me a pollutant of 40. So 40 equals negative 2x plus 50. Solve for that, and you get x equals 5. Or maybe I should have used t equals 5. Points for this problem. A is worth 1 point, an answer with a reason. I'm showing that P prime of 9 is negative, which is less than 0. B is worth 3 points, 1 for setting P prime of t equal to 0, 1 for solving for t, and 1 for a justification here. C, 1 point for the integrand, 1 point for the limits of integration, and 1 point for a conclusion with a reason. because it's less than 40. D is worth 2 points, 1 for the slope of the tangent line, and 1 point for the answer, t equals 5.